Hey everybody, so I might be interrupted here, so just be aware I might hear another voice soon. This is the second half of the chapter review, and remember this is due the day of your test. So let's go ahead and just get started. On our first problem, we have the temperature in Anchorage, Alaska in degrees Fahrenheit, and it's modeled by the equation F of T equals, and then you can see the equation, and T is the number of hours since midnight, from midnight to noon, and F of T is the temperature in Fahrenheit. So the first thing they want us to do on problem A is just label the axes. So this is my hours. I'm going to shorten it up. And then this is my temperature. This is my Fahrenheit. All right, so A is done. What I need to do is figure out what is the temperature at midnight. So this is from midnight to noon. So midnight is going to be where this begins. So that would put me right here-ish, that yellow dot. And it's kind of hard to tell. So maybe you're not going to think exactly what I think, but I think it is about 18 degrees Fahrenheit. Okay? All right, next problem. Sorry, I'm trying to do a little racing here. It's not liking it. Okay. So the next thing we're going to do is what was the lowest temperature that night? So the lowest temperature is going to be right here, and that is about negative 24 degrees Fahrenheit. But then part D says at what time does that occur? So that is the X value here. So if this is from midnight to noon, 6.5 would be at 6:30 a.m. So that 6.5 becomes the 6:30 a.m. So at what times was the temperature 0 degrees? So 0 degrees is going to be all across here. And so that happens twice. It happens at about 1.5 and at 11.5. And so again, if this is from midnight to noon, I would have a 1:30 a.m. time, and then I would have 11:30 a.m. time. All right, a point 10, negative 12 is on the graph. So what we need to do is explain what it means in context of the situation. So remember, X, the 10, is our hours, and negative 12 is the temperature, our Fahrenheit. So I would say in 10 hours, the temperature is negative 12 degrees Fahrenheit, and that's all I'm asking for. All right, we are going to write the equation in vertex form. So this is where the last thing that we talked about. So vertex form looks like this. It is a squared because it's a parabola, and I'll put an X here, and let me just do some erasing of these other points. All right, so what I want to see is, can I figure this out without this whole complicated thing? So how did my vertex get to here? Well, we know already that I went right 6.5, and then I went down 24. So right 6.5 will be minus 6.5, down 24 would be minus 24. But now I just want to see if I go over 1, can I figure out that nice number? So from the vertex, I got to go over one whole spot. And if I go up, I don't think I can tell what that is. So what I'm going to have to do is take some other random point. So you know what? I'm just going to use this 1.5, 0. And I'm going to put my A that I'll try to figure out here. I'll put my X value in for the X. And then when this thing equals Y, I'll put 0 in for Y. And then you're going to need a calculator here, no problem. But the first thing we had talked about is that we would add the 24 over. And then, because the stuff in the parentheses with the exponent is such a mess, we would just clean that up. So I get negative 5 in the parentheses, and when I square negative 5, I get 25. So A times 25. And now to move the 25 over, I would just divide it. and my A is going to be 24 over 25. So I'm just going to put that right there. It's almost 1, but it's not quite. All right, what is the average rate of change from midnight to its lowest temperature? So at midnight, we had already answered that question. So at midnight, the X value is 0, our temperature is 18, and to the lowest temperature, we had already answered that, and that was 6.5 with a negative 24. So all I have to do is remember my table, sturdy X's on the bottom, Y's on the top, the glasses, and 21 to drink. But I'm going to take my X's and go with 6.5, take away 0, which is 6.5. And then I'm going to take my Y's, which is negative 24, take away 18. When I subtract those, I get negative 42. And I do prefer that you actually divide these two numbers. So I'm using my calculator, and I'm going to get negative 6.46. And that's what the temperature is changing by, negative 6.4 degrees Fahrenheit every hour. And it's going down because of the negative. All right, back to chapter 1. Where is this decreasing? So if we talk about the graph that actually just matters here, it would just be from here until I get to noon the next day. So I would actually just stop there. And when I write these coordinates, this is 0, 18, this is 12, what is that, 6, okay? And when I need to talk about the temperature that's decreasing, I would start and work my way till I decrease. And let me put this point back on here, 6.5 with negative 24. And remember, we use the X values, so from 1.5 to 6.5, decreasing, always is in parentheses. When is the temperature positive? So that would be above my x-axis, so let me get to a different color here, and this little bit of here, okay, because I'm only worrying about the domain that really matters. All right, so one part will be from 0 to 1.5, and the other part will be from 11.5 to that 12. All right, that is our first problem. Let's go to the second one. This time we got a golf ball, and the first thing you're going to ask me to do is to label my axes. So this is the distance traveled, and I think it's all in feet if I read the problem. Let's see. Yeah, feet. And this is the height the ball went in feet. Okay. So A is done. What we want to do, approximately what was the height of the golf ball when it has traveled 90 feet? So 90 feet would take me to here. And then if I go up, I would say it's maybe 84 feet, maybe say 85 feet. So I'm just going to go with 84 feet. All right, next, let me do a little racing here. How far from the tee did the golf ball land? So that's right here. So how far from the tee, that would be, if you look at this point, that is the 300 feet. What is the maximum height of the golf ball? So that would be, oh gosh, right about there, I think. And so the maximum height the golf ball went was 100 feet. And then they're going to ask at what distance did it reach that maximum height. So I actually want both numbers, 150, 100, and that would be 150 feet. All right, what domain makes sense? So if I think about this, the domain is just going to go from here. This is the only part of my U that I care about. Let me keep going. All right, so then what I would do is I would write those coordinates. So we start with 0, 0, and to 300. So 0 to 300. There we go. All right, what is the average rate of change? So we're going to have our x's, so I might as well just put those in the denominator, because I always give you the x's. And let me do a little erasing here so I can clean some of this up. Okay. So what I want to know is if x is 25, what's that amount? And I would say that lands me right about there. So 25 gets an x value of 30, or sorry, a y value of 30. And if I go to 90, then I think I'd already answered that, right? And I said it was 84. So maybe you're going to go with 85, but I'll just use the 84 that was here. So if I subtract my y's, I get 54. If I subtract my x's, I'm going to get 65, and you can leave it like that. I do always prefer for you to divide it out, and we're going to get a not nice decimal, but I could just put it here. Okay? All right, where is it decreasing? So decreasing, again, if I only look at part of the graph that counts, it's decreasing right to there. And if you remember, I erased it. That value was 150, 100. So it's going to decrease from 150, the x value, to 300, the x value. And now we're going to write our equation. So let's see if we can write this equation. I don't think we're going to be able to, because I can't go over 1. I can go over 10 from my vertex, but I'm going to have to do this the long way. So if I start, let me do a little erasing here. Let's see, no, actually I'm going to keep everything here. So if I start my final answer here, here we go. I already know that my 0, 0 went right 150 and up 100. So I'm going to put minus 150 and plus 100. And then I'm just going to pick some other point. So I'm going to take this point, which is an x and y value, and just plug it into my equation. So I'll be doing that to figure out what a is, and then the x value will be replaced with 300. And the y value will be replaced with 0. And in the classes, we agreed that we would move the 100 over first. And then I would take a moment and clean all this up. So I would get 150, and 150 squared is, oh, a pretty big number. Oops, I mean not the highlighter here. A times this number. And now all I have to do is divide that 22,000 number, and when I do, this is what my A ends up being. And if you want, you can turn it into a decimal. Let me see if that's a nice decimal, though. It's not. So I'm just going to leave it as the fraction. So I'm not even going to simplify the fraction. Negative 10 over, I'll let that green bar be my fraction, 22,500. Okay, that is the first page, and I am going to stop the video there, and then the next video, excuse me, we'll pick up the second page.